Hello guys, I welcome all to Engineers Academy. Do subscribe my channel if you haven't done it yet. Now we are going to solve this problem which says that replace the force system by an equivalent resultant force and couple moment at point P. So we have to replace these two forces by the resultant equivalent resultant force and resultant couple moment at this point P. So it's very easy. We have to find the Rx component of the resultant. The Rx component of the resultant will be equal to the summation of forces along the x-axis, and towards the right is our positive x. So in order to apply this equation, we have to resolve both the forces. So as we can see that this 600 Newton force is making 60-degree angle with the horizontal. So we can resolve this 600 Newton force. We will have, this will be the cos component. We can write that this will be 600 cos of 60. And then we will have the sine component. This one will be 600 sine of 60. And similarly, this 455 Newton force will have one component in this direction, and we will have one component in this direction. And the angle of this force is given in shape of this triangle. Let's say, let me draw the triangle here. So we have the triangle like this. This is 5, 12, and 13. So we are going to consider this angle for 455 Newton. So this angle and this angle in the triangle, they are same angle. So let's say this is our theta. So now if we are going to consider this angle, then this component is the cos component of that 455. So I will write that this is 455 cos of theta, and this one will be 455 sine of theta. And now from this triangle, the cos of theta is the base divided by hypotenuse, so that is 5 divided by 13, and sine of theta is perpendicular divided by hypotenuse. So perpendicular is the opposite side to the angle, so that is 12 divided by 13. So now if we apply the summation of forces along x, is we can see that this cos component of 600 Newton, this is acting in the positive x. So I will write plus 600 cos of 60. And this component is acting in the negative x, this sine component. So you will write minus 455 sine of theta. Now this is sine of theta, 12 divided by 13. So 455 into 12 divided by 13. So this will give us the summation of forces along x. So this is 600 cos of 60 minus 455 into 12 divided by 13. This gives me minus 120. So this is equal to Rx. So Rx is equal to minus 120 Newton. Similarly, if we want to find the y component of the resultant, so we will add up all the components along the y direction, and in the upward direction is our positive y direction. So now as we can see that this cos component of 455, this is acting in the positive y direction. So I will write plus 455 cos of theta. Now this is cos of theta, 5 divided by 13. And we have this 600 sine of 60. This is in the negative y direction. So I will write minus 600 sine of 60. So this will give us the Ry. So Ry is equal to 455 into 5 divided by 13 minus 600 sine of 60. This gives me minus 344.62 Newton. Now these are the components of the resultant. We can represent this resultant as a Cartesian vector. So we will write that R resultant vector. So this is the negative sign tells us that our x has a magnitude of 120, and this is acting in the negative x. So we will write that minus 120i and minus 344.62 j. So this is the Cartesian vector representation of the resultant. And now if you want to find the angle of the resultant, let me show that. Let me draw the x-axis. Let me draw the y-axis. This is the positive x-axis. This is the positive y-axis. Now the resultant is the x component of the resultant is in the negative I, and the y component of the resultant is in the negative j. So we will write that this is 120 in the negative x, and we have that 344.62 in the negative y. So the resultant is acting somehow like this. And if you want to find this angle of the resultant with the x-axis, so we can find it. Let's say if I move this component here, so then we can find by applying tan alpha. So tan alpha is perpendicular. So this is Rx, this is Ry. So we can say that tan alpha is Ry divided by Rx. And we can say that alpha is equal to tan inverse Ry divided by Rx. So this is tan inverse. Now Ry has a magnitude of 344.62 divided by 120. So this will give us the angle of the resultant with the horizontal. So tan inverse 344.62 divided by 120, this gives me 70.80. Alpha is equal to 70.80 degrees. And if you want to find the magnitude of the resultant, so the magnitude of the resultant can always be determined by applying the Pythagoras theorem. So that will be minus 120 square plus minus 344.62 square under the square root. This will give us the magnitude. This is minus 120 or plus 120 square will give us the same result, since taking the square of negative sign is always positive. So 120 square plus 344.62 square, this gives us the magnitude of the resultant. This is 364.91 Newton. So this is the magnitude of the resultant. Similarly, we want to replace these two forces by a resultant. So we determine this resultant, the magnitude of this resultant. And let me erase now these components. There is no need to show these. So now we have this resultant whose magnitude is 364.91 Newton, and it is making 70.80 degrees with the horizontal. Similarly, we have to find the resultant moment. We have to replace these two forces by equivalent resultant force and resultant couple moment. So now we have to find the resultant moment. So we have to write that the resultant, the summation of moment of both the forces about point P, this will be equal to the resultant couple moment. So this will be equal to, we have to find the moment of this 455 Newton force. So this cost component is passing to that point. So we have to find the moment about point P. So this cost component is producing the moment about point P in the clockwise direction like this. So, and this is in the clockwise direction. So I will write the counterclockwise moment is assumed to be positive. So since this cost component is producing the clockwise moment, so we will write minus, and this is 455. Cos of theta is again 5 divided by 13, and the perpendicular distance of this cost component from that point P is 1 meter. So we will multiply this with 1. Similarly, this sine component is producing the counterclockwise moment about point P. So we will write plus, and this is 455. Sine of theta is 12 divided by 13, and the perpendicular distance or the moment arm of the sine component from that point P is 2 plus 0.75. So this is 2.75. So I will multiply this with 2.75. Similarly, this cost component is passing to that point P. It's not going to produce the moment about that point P, since the moment arm of this cost component from that point P is 0. So this sine component is producing the counterclockwise moment about that point P. So we will write plus, and this is 600 sine of 60, and the moment arm of this component from that point P is this perpendicular distance, which is 2.5 plus 1. So this is 3.5. So we will multiply this with 3.5. So let's find all this sum. This will give us the resultant couple. So this is minus 455 into 5 divided by 13 into 1. So there is no need to multiply by 1, plus 455 into 12 multiply by 2.75 divided by 13, and then we have plus 600 into sine of 60 multiply by 3.5. This gives me 2798. 2798.65 Newton meter. So this is the resultant couple that was produced by both of these forces. So now if we want to replace this force system by an equivalent resultant force, so that's a force, and we have to show, and we got this as a plus sign, right? This is plus. So the plus sign tells us that this is the counterclockwise moment. So let me represent this. So this is equal to the resultant couple. This is equal to plus 2798.65 Newton meter. So now we have replaced both of these forces by equivalent resultant and equivalent couple moment about that point P. Sorry, this is the origin. We need to move. We need to show these at point P. Sorry, I have drawn this mistakenly. Let me show that point P here. We have that point P here. So now we need to show these force and couple at point P. This is point P. So we will have that resultant somewhere here like this. It is making that same angle, which is 70.80. The magnitude is 364.91, and the couple moment is like this. Resultant couple, this is equal to plus 2798.65 Newton meter. So this is the solution of this particular problem. I hope it will help you in your learning. Let me know in the comments if it helps in your learning. Do subscribe Engineers Academy for the solution of such more problems from Hibbeler Statics.